Hello friends, this video on aldehyde ketones and carboxylic acid part 12 is brought to you by examfear.com. No more fear from exam. Let's take some numericals. You have to tell the reagents required to bring the following transformation. The first is hexanol to hexanal. So if you see, I am doing a transformation from alcohol to aldehyde. As I told already, you have alkanes. From alkanes you make alcohol. From there you make aldehydes, and then you make carboxylic acid. This is all oxidation method. So you keep oxidizing it. From alkanes you get alcohol and aldehydes and carboxylic acid. Now we have to make from hexanol to hexanal. So if you see, what we can do is we have to use some oxidizing agent, correct? That is for sure, because we are oxidizing alcohol to aldehyde. But if you use strong oxidizing agent, it will oxidize to carboxylic acid, correct? And we don't want that. So we want a weak oxidizing agent which will oxidize alcohol only to aldehyde, right? So for this we need weak oxidizing agent, correct? And this can be PCC. The next is cyclohexanol to cyclohexanone. So I have my cyclohexanol to cyclohexanone. This is the requirement, right? So to remove hydrogen, two hydrogens, I can do dehydrogenation or I can do oxidation. Any of this is fine. So I can use here K2Cr2O7. If we want to go for oxidation method, obviously in acidic medium, or I can also use copper. I can heat in copper, right? And with that also I'll get the same value, same thing. But here I am using dehydrogenation. So we have discussed these reactions, right? So either you remove two hydrogen, you use dehydrogenation, you use heated copper, or you use acidic K2Cr2O7, you go for the oxidation method and oxidize this alcohol to ketone. So any of these can be used to achieve cyclohexanone from cyclohexanol. Correct. Let's go for the next numerical. Here also we have to give the name of the reagent to give these transformation. The first is fluorotoluene to fluorobenzaldehyde. So let me first draw para-fluorotoluene. This is my toluene, and at para position fluorine, and this I want to convert into para-fluorobenzaldehyde. Yes. So I have various options actually. One option is I can use CrO3 in presence of acetic anhydride, or I can use CrO2Cl2. So there are so many options. One is I can use CrO3, I can use CrO3Cl2, and then water. In both cases I have to use water also. Or what I can do is I can use first chlorination Cl2, and then I can use water, because with this H2 will be replaced with chlorines, and then I can replace the chlorines with water. I have 2 OH and 2 in one carbon, so it will remove water. You can easily remove water from that, and you'll get C double bond O. We have seen this kind of stuff, correct? So for such kind of thing, it removes water immediately, and you get something like this. So you can use any of these methods. This is for the first one. So the next is ethane nitrile to ethanol. So ethane nitrile is what? Metheth ethane nitride to ethanol. So there are two ways actually. One is I can use Stephen reaction where I use SnCl2 and HCl, right? With that also, and then followed by hydrolysis, I'll get the same product. Or we have studied this reaction actually. And the second can be I can use diisobutyl aluminum hydride. Diisobutyl aluminum hydride. We can use this. So what I am doing is we are reducing actually. So if you see, we are reducing the nitrile to aldehyde. So we can use any of these. And this is also followed by hydrolysis. So the next is allyl alcohol to propanol. Again, alcohol to aldehyde will use weak oxidizing agent, that is PCC. Pretty easy, alkyl to alcohol, just we can use weak oxidizing agent. Just to be double sure, let's see the allyl alcohol. Allyl alcohol looks like something this. Right, this is my allyl alcohol. And propanol is meth with propanol. This is my propanol. You have to add extra hydrogens. Yeah, CH2. This is my. If you see this, everything is intact. Only my alcohol is converted to aldehydes. Will use PCC. The next is butene to ethanol. Next is butene to ethanol. Meth with but 1 2. Butene is this. Ethanol is meth with ethanol. This is my compound. Let me put all hydrogens. Correct. Now we have to break it actually, to break some here, right? Because we need two of these. So what we can do is we can use O3. So if you use O3, what will happen is in this, if we use O3, so we have seen this reaction, we'll get ozonide. Correct? Something like this. And then it will break. Again on hydrolysis and heat, what you get is CH3C double bond OH. This one. This is what you get. So you can easily get by O3 and zinc dust. Actually, you use zinc dust here. Yeah. So I think you have to use O3, and here instead of hydrolysis you use zinc dust, or you can use hydrogen in case of with palladium. So anything you can use actually. You can use zinc dust and hydrogen, or you can use zinc dust with palladium catalyst, and you'll get this. Here we have to write the products of the output. So if you see, this is my Friedel-Crafts acylation reaction. It will become AlCl4 minus, and this becomes a carbocation. So let me, and this will be attached here. So what you get is, this is my benzene ring, and you'll get this AlCl4 minus, and you'll get this compound, carbocation C2H5. Now this benzene ring, it will attack this guy, and the hydrogen will replace, and you will get something like this. This is what you get. So the reaction mechanism, if you want, I've just discussed in the past few slides. You can go through that. The next is you have this alkyne, and you react with Hg2 plus in presence of S2SO4, right? So what will happen is carbocation will be formed here, stable carbocation. So it will go in this fashion. H plus will attack this carbon. You'll get a carbocation. So let me first form the carbocation. Bond C Yeah, this is the carbocation that will be formed, and then you have water here. So I think OH minus will come somewhere here. So this will go off, and then this is a triple bond. Yeah, correct. Now this OH minus, right, will go here and form a double bond here. Yeah, this is what will happen. This will become H plus, go in this fashion, oxygen is more electronegative, and this bond will also break. Oxygen gets a negative charge, in this case carbon gets a positive charge. So that is what will happen. We have seen this kind of reactions, right? So this is the output for this reaction. For this, we have seen this. This is my CdR2, right? So CD has, this is how it looks. CD has +2 charge and it has minus charge, -2 charge, -1 each. So if you have seen CD +2, R minus, this is how it looks, CdR2, right? And it's a weak nucleophile, this R2, R minus actually. And we have the CH3COCl, this is acyl chloride. So what will happen is I have my CH3COCl and I have my, let this be R, assume, CD. R is a negative charge, R will have negative charge, this will have positive charge, and since this is electronegative, it will get slightly negative charge, slightly positive charge, and chlorine will attract electron towards it, so it will have all the more positive charge. So it has all the more positive charge. This R will attack this carbon. So what you get is CH3COR, and this chlorine will come out. Right? This bond will break and chlorine will come out. This is what you'll get. And here R is what? R is my CH2 and C6H5. So instead of R, let me replace R with CH2 C6H5, that is my phenol. This will be the output. Yes, this will be the output. Correct. This reaction we have seen is oxidation of methyl benzene. So what will happen is, in the first case, so it will become CH and other two will become here OCrO HCl2, I think, yeah. Correct? And this is NO2. And the next step is you do hydrolysis. So what will happen? These two will be replaced by the OH. So what you get is CH, OH, OH and NO2. So two bulky OH group in one carbon, it will not be able to withstand. So one water molecule will come out in this fashion. Yeah. So what you get is minus H2O. What you get is this guy. This is what you get. Yeah, this is the output. You can say para-nitrobenzaldehyde. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.